from last week punya tutorial class. So supposedly today kita akan proceed lagi dengan last week sebab yang yesterday class tu yang I bagi that recorded video, that one for example number 2. So this one for example number 1 and we proceed with example number 1. Okay. So last week kita stop here that we finally have the numbers of bar and so on, and last week pun kita dapat bending reinforcement dia uniformly distributed. Okay. Jadi for the next step what we're going to do, kita akan check for vertical transverse shear. Okay, we're going to check for this. We're going to use what is it? The formula V equal to PS and darab dengan area lah ataupun E . So PS is the ultimate earth pressure which is 256 kilonewton per meter square as last week punya. Mana PS kita last week? 256. So 256 kilonewton per meter square. Okay, and then we need to darab dengan the area. So area yang mana yang actually for transverse shear. Okay, area dia is the one yang macam ni lah. Separuh saja daripada your, what is it? Foundation. Okay, so this one supposedly is 1.0D. Daripada face of the column, it is 1.0D. So what is D? D is effective depth. Okay. So 1.0D, 1 darab D. D kita berapa? 540. Okay, tak pasal susah tengok jauh-jauh kat sini dah ada 9D ni. So you boleh tengok 9DD 940. So we just simply use 1 darab 540, so it become 540 kat sini. Okay, and we know that if half of this foundation, it is berapa foundation? 2500 kan? This one example 1 so 2500 dia punya width. So half of it is going to be 1250. Okay, and kita punya width of column is 200 lah, half of it sebab width U column U 400 untuk example number 1, so separuh dia jadi 200. So macam mana kita nak dapat berapa ni? Sebab kita nakkan this area kan. Area ni kita dah tahu 2500, tapi area yang kita tak tahu. We need that area, that particular area untuk calculate the transverse shear. Okay, berapa area ni? So how we going to do that? 1250. We just minus lah dengan this 200 which is half of your column punya width, and minus lagi dengan 1.0D which is 540. Okay. So you're going to get some answer. Hafizah say 510 mm. Okay. So 510 mm. So this one akan jadi 510 lah. Okay. So kita sebenarnya nak kira area ni. Because this one yang affected by vertical and transverse shear. Therefore, kita darab je dengan 5 meter. So area kita is 2.5 supaya kita tukar jadi meter, and darab dengan 0.51 meter. Okay, itulah jawapan 326.4 kilonewton. So this is the vertical, the shear force lah. Okay, shear force. Alright, and then what we need to do next is we need to calculate for shear stress. So we have the formula which is shear force divided by BD. Okay, so 326.4 darab 10 kuasa 3. Kita tukar dia jadi Newton and bahagi B here is 2500 and times with the D which is 540 mm. Syahrul Daniel yang bawah tu 2500 because it is from meter, you kena convert dia kepada millimeter sebab biasa kan kita kira shear stress Newton over mm square. Saya bela-bela lah Miss tak nampak. Dia jangan confuse, tu bukan point tau. Sebenarnya kalau saya buat macam, kalau saya buat titik macam ni, is a titik lah. Macam ni kan, kalau you nampak lah. Okay. Bila I buat terpanjang macam ni, sebab I macam, kalau I buat macam ni, dia ada macam ni koma. I suka macam tu supaya I nampak berapa I tulis tu. Kadang-kadang kita tendency untuk tulis terlebih kosong, terkurang kosong. So bila you buat koma tu lebih nampak. 0.242. Okay, betul. Thank you. Okay, 0.242 Newton over mm square. And then kita akan kena check VC lah because we need to compare value shear stress for vertical or transverse shear ni, whether it is bigger or less than VC. Okay, so kita check VC VC is equal to, as usual, the formula yang panjang. As usual, 100 AS divided by BD ni kita buat outside lah so that kita tak confuse. 100 AS divided by BD. Okay, so 100. So here the AS provided bukan AS required So you just ambil je AS provided which is mana AS provided kita? Okay, ini 1890 mm square. Okay, yang kita provide, yang kita letak berapa banyak bar tu kita ambil that one 1890. Divide by B, so the B is 2500 mm and D is 540 mm. Okay, so here I'm going to get some values. So I dapat 0.14. From this one, kita dah ada this 0.14. Nampak? Okay, we can just put it inside. Kuasakan 30.14 darab kuasa 4. Okay, so kat sini because of our D is 540 which is bigger than 400, so automatically kita akan pakai 1. Okay, because of, you know, when D is bigger than 400 mm, okay, automatically punca kuasa 4 400 divided by D akan jadi 1. Okay. So because of D kita besar 940, jadi this is 1 So that's why I tulis ini 1 lah. Nampak. Because of our FCU kita berapa? 35. Kita boleh check balik FCU kita berapa. I pun tak ingat. Our FCU is actual. Soalan. FCU kita 35 Okay, jadi bila 35 obviously FCU kita tak sampai FCU kita bukan 25. So automatically akan ada tambahan dekat sini. Additional, we say that FCU divide by 25. Okay, so FCU kita adalah 35 Newton over mm square. Kita kena bahagi kuasa 3 tinggal bagi dengan 25. Okay. So and divide with the gamma m. Gamma m is fixed 1.25. Point tak nampak. I dapat 0.367. So we're going to check this value dengan our value V ni 0.242, and it is obvious that our V is less than VC. Okay, sebab V awak 0.42, VC 0.367. Okay, so which means that no shear reinforcement is required. Okay, we are done with vertical and transverse shear. So last kali kita akan check for punching shear. Okay, punching shear basically cara dia sama je, tapi area dia lain-lain lah. Tu je yang membezakan between vertical and transverse shear. Vertical transverse shear dengan punching shear, sebab area yang being affected by this, kita nak kira based on areas. But area ni yang akan possibility, area ni yang the higher possibility to actually mungkin ada macam like punching shear macam tu. Tapi mungkin area ni lebih kepada transverse shear macam tu lah. So that's why area dia lain-lain lah. Okay, so for punching shear, sama juga formula V equal to PS darab dengan P. Okay, but the area is different. Okay, tulis je. So area kat sini, macam mana punching shear, kena lukis lagi. Okay, and punching shear dia akan happen dekat keliling foundation. Okay, which is dia punya jarak ni is 1.5D from the face of the column. Okay, so since the D for this question is 540, so 540 you darab je dengan 1.5, you akan dapat 810 mm. Okay, and as we know, sebab kalau kita nakkan mana area yang punching tu, area yang ni area ni yang I shaded dan ugly. So kita nakkan this area, which means kita ambil area yang besar ni, punya area apa ni, foundation you kat luar ni, area besar 2.5 times 2.5, kita boleh minus dengan area yang kat dalam, dan kita akan dapat area yang keliling dia ni lah. Berapa So itu yang akan kita buat But then we already know area yang kat dalam, area yang kat luar, which is 2.5 times 2.5 meter. Obviously area dia, tapi area yang kat dalam ni we don't know. Okay, so kita nak dapatkan berapa panjang ini. Okay, and to get that, we know that this is 1.5D. So obviously kalau sini 1.5D, sini pun 1.5D. So it should be 810. And this one also 400. Kita punya column width. Okay, so 810 times 2. Okay, and kita akan campur dengan 400. Okay, so I dapat 20 tahun ni So panjang ni adalah 20 mm. Okay, so kita dah boleh lah dapatkan macam mana saya nak dapat area yang I shaded kan tu. Okay, so kita ambil area yang kat luar, which is 2.5 meter darab 2.5 meter. So tak payah tulis susah-susah, kita kuasa 2 kan je. Okay, 2.5 meter times 2.5 meter. That is the area. And we're going to minus with area yang kat dalam, which is 20 tu untuk one side. Kalau 20 darab 20 lah, baru kita dapat area dia. But we need to tukar dia tu meter. So 20 akan jadi 2.02 meter. Okay, nak dapatkan area, so kuasa 2 lah. And we're going to get something like this. Farah Nadia, 555.418. Okay. So thank you. 555.418 kilonewton sahaja. Then we need to calculate the shear stress so that kita boleh compare dengan VC, which is concrete shear stress. Okay, tapi formula dia lain sikit, which is V equal to V besar, which is this V, but perimeter ataupun circumference, as budak-budak millennial panggil, darab dengan D. Okay. So D is effective depth, but ada perimeter kat sini. So we need to find the value of perimeter. So perimeter ni apa? Okay, perimeter ni inilah. Perimeter yang mana? So perimeter ni lah. 20, 20, 20, 20. Okay, so obviously sebenarnya 20, 20 you darab je dengan 4. Okay, so you dapat lah panjang semua yang keliling area tu . So perimeter equal to 20, 20 darab dengan 4. Okay, tak payahlah tanya, senang sangat. Tertinggal. Okay, 80, 80 mm. Okay, jadi kita boleh kira the shear stress, which is ambil saja value V kita, 555.418 darab 10 kuasa 3 divide with the perimeter 8080 mm and darab dengan 500. Okay, Mac, berapa Mac? 0.127 Mac kata. Betul. Okay, thank you Mac. 0.127. Laju betul dia. So kita dah dapat the value of V. Kita boleh compare lagi dengan VC. So actually the VC kita masih lagi sama, tak berubah. Sebab macam mana boleh berubah, kita punya concrete shear stress kita masih lagi pakai area yang sama and so on. So sebenarnya bukan area yang sama. Our foundation masih lagi size yang sama and pakai concrete grade yang sama. So takkan berubah VC ni. Once kita kira, itu adalah VC value dia. Kita compare je dengan VC ni 0.367. Okay. Obviously V is less than VC. So which means that punching shear is unlikely to happen. Sebenarnya kalau kenapa punching shear ni happen, sebenarnya you tak provide enough effective depth. Maksudnya you punya mungkin too shallow lah. Okay. Back footing you mungkin terlampau shallow, terlampau thickness dia tak cukup. Okay. Ataupun effective depth dia tak cukup. So that's why akan terjadi punching shear. Mungkin you punya it's unlikely to occur and 600 mm depth is acceptable. Okay. It's unlikely to occur tu tak bermaksud dia takkan terjadi. Okay, this is like design, but things happen. Especially when there is a groundwater and such, movement of earth, blah blah blah. So structure failure can happen. Okay, so kita dah almost finish. So sebenarnya kita nak melukis last sekali. Kita pun akan lukis. Dia besar. Semakin besar, semakin buruk. Okay, so this is plan view yang sengit. Jangan lukis macam saya, kolom saya sengit je. Malas nak betulkan. So this is 2,500 and you have also 2,500. Okay. And then kita ada bar, okay, which is bersilang lah. Okay. So this is the bar. Tapi kita tak payahlah lukis semua because kita nak label. So kalau terlampau banyak sangat garisan-garisan, tak senang juga nak tengok drawing kalau banyak sangat garisan. Okay, so here kita label lah. Buatlah macam ni. Okay. So kita pun tulis lah 6Y 20 dash berapa hari tu ah? Dia punya spacing lupa. Check balik spacing that day, it is 460 ya. So this is our spacing, so you just use that 460 mm spacing. 460 both way. So apa maksud both way? Meaning that longitudinally and latitudinally bar dia sama. Okay, dua-dua arah dia sama. So this one is for plan view. And we have another view which is the side view ataupun cross section view. Lukis saja. Okay. Kena potong lah and then you have like this one which is your main reinforcement also you jangan ingat bawah ni bukan main reinforcement. Dia ada dua layer. Atas dan bawah. Patutnya I buat colour lain. Lah, ada tu buat colour ni. Okay. Terus dia adalah main reinforcement, so I pakai colour yang sama. Nampak tak cukup tempat? Patutnya dia sama lah spacing dia. Sebab miss tangan tak berdung. Okay, so the effective depth mesti sampai in between bar ni, sampai sini lah. In between bar, so it is 540. Okay, and the total height is 600. Okay, number of bar mesti betul Kalau 6 tak 6, kalau 10 tak 10. So ada markah, saya kira berapa biji bar. Tak cukup, I potong markah. Okay, yay, we are done. So this is our final sketch for this question. Okay, kita habis cepat. Ada soalan? Nak tanya example 2 tu miss. Okay, Magdalene, you can ask what is it? I check balik. I minute salah kah? 0.44 salah miss. I bagi jawapan salah ke? 0.41957 bla bla bla. 0.42. Okay, sorry, tukar. Dalam video pun 0.44. Okay, mungkin gila. So never mind, you tukar je 0.42. Tukar balik jawapan dia. Alright, thank you so much everyone. Have a nice day.